In the previous video, I talked about calculation of the sample size. And in this video, I will talk about the sampling methods. It is very important to have an accurate calculation of the sample, an appropriate method of selection to avoid bias, so that the data of the research will be accurate, valid and reliable, and generalizable. The sample should be adequate and representative to the target population. Now let us delve into the problem to see the types of sampling. Simply, there are only two types of sampling, It is the probability sampling or non-probability sampling. Just two types, probability and non-probability. But each one has got 4 divisions. Each one has got 4 subtypes. And let us now delve into the subject and see, as I said, that the sampling method and the sample size ensure good representation of the population under the study. And a correct sample size and proper sampling will ensure accuracy and validity of the results. This means the conclusion will be generalizable to all similar settings, like the settings in which the research was performed. The sample method should be, as I said, representative and adequate to give correct results. It should be representative to the target population. And to define the target population, we should describe exactly the characteristics and the features of the population we are going to study. If we are speaking about a certain type of surgery, we should describe the type of surgery performed in, for example, young adults and elderly patients, or only in elderly patients. Our population, is it elderly patients or inclusive of the younger generations as well? If it is about surgical site infections, is it in all types of surgical surgeries or in a specific type of surgery? We should define the target population first. And we should also define the inclusion and exclusion criteria, so that the work will be very specific. And we should choose an appropriate method for sampling the target population. The target population usually is denoted by the letter capital N and the sample by the letter small n. As I said, there are only 2 types of sampling. It is either probability sampling or non-probability sampling. The benefits of probability sampling is that it avoids bias. It avoids selection bias. And it allows a generalization of the results. The probability sampling has got 4 types. The other type of it is, I said either it is probability or non-probability. The probability sample gives equal chances for selection of the individuals for the sample. It gives equal chances for selection of the individuals, while the non-probability does not give equal chances for selection of the individuals. Hence, there is a bias of selection in the non-probability samples. But each type of sampling has got its indications. Now let us speak about the probability sampling, which avoids as much as possible the bias of selection. It has got 4 types. The first one is the simple random sample. The first type of the probability sampling is simple random sample. And the simple random sample, in the simple random sample, every one in the sample, in the target population has got equal chance to be selected into the sample. There are equal chances for selection of each and every one in the target population to be selected in the sample. It has a methodology to be done. And the second type is the systematic sample. Now let us go back to the simple random sample. In the simple random sample, we have to start randomly by selecting the first case. And then for the rest of the cases, either we just plot all these cases into a paper sheet in numbers from 1, 2, 3, 4, 5 to the end of the individuals in the population to select from, or we put the names or the identification number of each individual in a small paper, and we fold it several times. We put it in a cup and we shake the cup several times to mix the papers very well so that no one will know which is which, and then ask somebody to select the first one. This will be the first one to be selected in the simple random sample, and then we'll keep selecting from the mixture, from the whole lot in which were already mixed together, not identified, just to select, and in this way, this is like a lottery sampling, or by generating an online number generator, and then we select the numbers, and every individual should have a number representing the individual. We select the numbers from an online number generators, or by a lottery sample by just mixing the identification numbers and mixing them together and putting them in the cup, mixing them together, and then start selecting. This is a simple random sample. The systematic sample is that we have a system for selection. The first case will be selected randomly. Then we go by a specific system. Every second patient, or every third one, or every fourth individual, or every fifth or seventh individual, like this. It should be fixed intervals. It should be fixed intervals. We will going to see it in a minute. Now, look at this sample on the left-hand side. It shows a mixture of the individuals in the population. First, we take randomly one, and we give them numbers starting from 1 to 15. And then we fold in a paper, we write in each small slip of paper 1 in another stereo paper, 2 in a third one, 3, so on and so forth to the end of 15. We fold each paper several times, we put them in a cup, we mix them, we shake them very well, and then start selecting. This is how we select the simple random sample by lottery method. Or these numbers will be plotted in a paper, and then we start ticking from the paper randomly. Or we know the size, we have already calculated size. We tick the numbers till we reach the size, or we select from the cup till we reach the size we have already calculated. Either lottery method or online number generator, or in a paper writing numbers. This is a simple random sample. Now let us see the systematic random sample. The upper line shows the individuals in the target population from 1 to 11. And selection is started randomly by taking number 2, just like that, taking randomly number 2, the first one. And then every fourth individual was taken. Every fourth was taken. So randomly number 2 was taken. Then the fifth, number 5, we missed 2, 3 and 4. Then we missed another 2, 6 and 7, and we selected 8. And we missed intentionally. We left, we did not take number 9 and 10, and we took the fourth, number 11. And this is a system in which we go systematic selection till we reach the number calculated in the sample size. Now let us see the third one. The third type of probability sampling is the stratified sample. In this type, we classify the target population into strata. For example, if you are studying, let us say, surgical site infections in the general surgical ward, and then we stratify them into children, young adults, and elderly people. These are strata. And then we take from these strata randomly the number we need to take to satisfy the number of the sample size. So we select first, we put the society or the target population into strata. For example, emergency and elective surgery, we put them into 2 strata. And then we started selecting. A selection from each strata will be in the method of the simple random sample, the first one. I hope this is clear. The characteristics of this is that these strata are homogeneous. The individuals in each strata are homogeneous. In the children, in the young adults, and in the elderly are homogeneous. Opposite to this, the fourth type of the probability sampling is cluster samples. Let us speak about, for example, schools or medical schools. If you would like just to interview students or teaching staff, we have something about 40-something or more medical schools in Sudan. Then we put them into clusters. There are 2 governmental schools in the north. There are 2 or 3 in the east, Kassala, Gadarif, and Port Sudan. There are also so many in the west, Al-Fashir, Al-Ubayd. For example, we have different clusters. From each cluster, we take by simple random samples, we have 40 something. In schools of medicine, we take from each group, from the north, from the west, from the center, or from the west, we take some of these clusters by simple random sampling of the clusters. And inside the clusters, because it is heterogeneous, it contains all types inside, all sorts of individuals. Then we start selecting from these clusters the individuals you want, whether they were teaching staff or students for the interview. These are the clusters. So we have 4 types of probability sampling: the simple random sample, and the systematic sampling, the stratified sample, and the cluster sample. And let us look at the stratified and the cluster samples. This is a systematic sample we spoke about before, and look at the target population on the left hand side. So many. We classified this target population into 4 strata: those who are wearing in green, and those who are wearing in blue, and those who are wearing in purple, and those who are wearing in black. And then from each strata, we select randomly. These strata are homogeneous, or green, all blue, all purple, all black are homogeneous. We take from these by a simple random method from each strata. By a simple random method, we take our samples till we reach the sample size we have already calculated. This is a stratified random sample. And this is the cluster random. Look at the target population on the left-hand side. It is composed of about 8 clusters. 8 clusters, 8 medical schools, or 8 primary schools, or 8 hospitals. From these 8 hospitals, which are heterogeneous, containing different types, then we select randomly our target random sample. We select it till we reach the number of the sample. From the clusters, we select the clusters, 8 clusters, we select 4 clusters by simple random sampling. Out of 8, we select by simple random sampling 4 clusters. And then from the 4 clusters by simple random sampling, we select the individuals for the sample of the study. These are the random samples which tries as much as possible to eliminate bias. Now, let us take some examples of simple random sample. For example, association between preoperative risk factors and surgical site infection after elective abdominal surgery amid Sudan war, a case control study. Now from this we can select a simple random sample just by an online number generator, or we plot the numbers in a paper and we select the numbers, or by a lottery method, a simple random sample for elective abdominal surgery. First, we have to define the population we are the population with infection, and we have to define with infection means we are going to use the definition of surgical site infection according to the definition of the Centers for Disease Control, whether it is superficial infection or it is deep infection or it is organ-related deep-seated infections. According to specific criteria, then we define our inclusion and exclusion criteria. We are going to exclude, for example, diabetic patients. We are going to exclude those immunocompromised, those who are receiving steroids. We are going to define the inclusion and exclusion criteria. And if we are using a control, those who did not, we are going to use those who did not develop infection among the group in the surgery department. And it should be with similarity either of age or the type of surgery. For example, we only do a research in cholecystectomy, surgical site wound infections, like that. And the proportions between the group in which we are studying the exposure, which is the surgical site infection, and the control group can be 1-to-1, the ratio, or it can be 1-to-2. And we use a random sample generator or a lottery generator for the samples, simple random samples. This is the same thing. We already defined the target population. We create a list to ensure no duplicate. When we enter the data into the computer, we should make sure that the data of each individual should be inserted into the computer, but there should be no duplication. No individual should have its data twice. And we should make sure that the entry of the data is correct, of the individual data, and we should make that there is no missing individual. All data were entered and no doubling of individuals. The data of one individual is not entered twice. This is what is called cleansing or cleaning of the data. And we, as I said before, we define an identifier to select the sample. This number 1 was chosen randomly, and then we generate either online number generator or by a lottery sample and select the rest of the sample. Sometimes there are some problems, and the problems were that if for example, in the situation of the war now in Sudan, if we are doing a retrospective study in the medical records, some files might be missing because of the chaos of the war itself. For this reason, to correct this deficiency, we have to add between 10 to 20% of the sample size. We add it to the sample size to compensate for the lost files. And we have to also observe the data cleaning. As I said, not a single individual should have his data entered twice, and the entry should be correct for all variables, and and in the sample, all patients were entered into the computer for analysis. No one should be missed. However, sometimes, also in prospective studies, when we are following patients, in the follow-up during war, we might lose patients. If patients will be lost, whether they die at home or they will be displaced to another place or another city or anything like that, then we have to include some more individuals between 10 to 20% to compensate for the attrition, for the loss of files or the loss of individuals in follow-up. If there are some individuals and their variables, their data is not complete, this is a problem. This, as I said in the previous video, should not be eliminated, these individuals. If we eliminate them, then the sample will be small and it will not be representative, it will not be adequate, it will not give accurate results, and will be difficult to be generalized. So we keep them and we correct them by statistical method, and a statistical method called imputation. Not amputation. Amputation is removal of part of the body. Amputation. Imputation is ta'wid, replacement, but by statistics. It has special methods. For continuous data, they use the mean and median, and for the categorical data, they use the mode, and this is another subject. We need a statistician to talk about it, or we may try to speak about it some other time. So this is about the limitations. If we find problems, how to correct the problems when we select our sample. Now let us take examples so that the subject of the probability sampling will be clear. The first example is a title of a research, Evaluation of Surgical Site Prevention Protocol. Now we are speaking about prevention protocol across different age groups. Prevention protocol in children, prevention protocol in young adults, prevention control in elderly patients. In this case, we are having our protocols and we need to see whether it is applied correctly in these different strata. It is example of a stratified random sample. And the second example is assessment of risk factors and complications in elective versus emergency general surgical operations as a stratified random sample. We have two strata here. It is the elective surgery and emergency surgery. And we would like to study the risk factors and complications in each one of these, in the elective and in the emergency operations, in two strata. The third one example is outcomes of resuscitation in trauma versus non-trauma in general surgery. Resuscitation can be for cases coming up to the emergency room with sepsis. They come in sepsis with hypotension and they need resuscitation. And some of them elderly patients might come with cardiac event or with a CVA, cerebrovascular accident. And some of them might come in shock with trauma. So we have two categories. We have two stratas, trauma, non-trauma. And we would like to see the outcome of resuscitation in each of these two strata. Now let us talk about the non-probability. Before going to the non-probability data, we should remember that the probability data is the probability sampling. The probability sampling minimizes the chance for bias of selection, and it uses 4 types of probability sampling: simple random sample, and systematic random sample, and a stratified random sample and uh, clusters random sample, cluster samples. Now we can move to the non-probability sampling, in which usually it is difficult to access the population to select the sample. There is some difficulty in accessing the general population to select the sample. So it has also 4 types. And now we see the 4 types of the non-probability sampling. The first one is the convenience samples, which is used by so many of the registrars. It's just selection of participants who are easily to access. All the numbers, we are studying something in the general surgery, we collect all the patients in general surgery, easy to access. The bias is that there is not everyone has an equal chance for selection. So we select them all. We select them all. And that is a convenience sample. Now the snowball. The snowball is that you select first some cases and you ask these individuals to nominate for you other people for selection. And they nominate for you some. And then you ask the second line people who were already nominated again to nominate some people to be added to the sample size. And so on and so forth. Every group will nominate another group, and there is a bias. Probably they will nominate their friends, or they nominate people with special criteria. So there is a chance for bias. It doesn't eliminate bias. The snowball. But as we go on, the sample size will be increasing because the individuals nominate more. And the selected individuals themselves will nominate more, but it is not randomly selected. There is bias in the selection. So now we have 2 types. The convenience sample, we take all of them, or the snowball sample, in which each group selected will nominate the coming people, and then they nominate also the rest, and so on and so forth. For example for the convenience sample, post-laparotomy complications of consecutive patients operated by a surgical registrar over 12 months. It is convenient, all patients. I think this is important because it gives reflections to the Sudan Medical Board the real activity of the registrars over 12 months. What are the patients they have operated, they have managed, and what was their complications, and why they developed these complications, and how did they deal or handle these complications. It will give an idea to the training, how the training is going on. And I think every year at least 2 or 3 registrars from different areas in the country should be allowed to do this, to give a feedback of what was happening during their training for 12 months. All the series of their cases. Somebody might write about all general surgical cases he has done, or might select only the appendices he has done in 12 months, or might select hernias or cholecystectomies, and then we'll analyze the complications, the hazards, and the outcomes, and the reasons, the correlations and associations in his study. This is just a convenient sample for one registrar, what he has done throughout 12 months. For the snowball, which will keep growing, the sample will keep increasing in number. Registrar management of acute appendicitis amid Sudan war, a cross-sectional snowball sampling analysis. Now, this is not one registrar because we have to nominate. For example, the registrar researcher can nominate 3 registrars in his hospitals to select their cases they have operated, the appendices they have operated, and to analyze their data. And the 3 registrars will nominate another 3 registrars from another hospital. Then he has to contact the other hospital and ask the other registrars, the 3 or 4 or 2, and collect their appendices and analyze their data and add them to their sample. I mean, they add them to the sample. And those in the second hospital can nominate another 2, 3, or 4 registrars in a third hospital, and also he collect all the appendices they have operated. Now he has got a bigger sample of appendix operations, and he will carry on the analysis and will find out the presentation and the complications and the outcomes of their performance. Such a study will reflect the performance of registrars in one type of surgery in different hospitals. And I think also it gives an idea about what is going in the different hospitals. And then we can compare the training in one hospital, in the 3 hospitals, and see the load of work, where it is of high magnitude or less magnitude, and the outcomes in the different hospitals. So this is an example of a snowball sample. Now for the quota. The quota, which is a non-probability sample, it is a non-random sample. Selection of participants according to preset criterion, for example, elderly. This is the third type. The third type, we said the previous 2 types of the non-probability were the convenience sample and the snowball. And the third is the quota. The quota is a selection of participants according to preset criterion. For example, elderly, only elderly males. The bias arises from non-random selection from the quota. Usually the quota here is heterogeneous. It contains males, females, it contains young adults, and it contains elderly patients. And the selection here is only for the elderly patients. This is the quota sample. And the last, or the fourth one of the non-probability, non-random sample is the purposive, purposive sample. Here, usually we select according to our own purpose. For example, we want a group of doctors to evaluate the thesis of the registrars. Then we select only those who are highly specialized in research, for example, not all consultants. So there is some selection bias. But that was our target. It carries high bias of selection, but it is our target to look for certain criteria of certain individuals by purpose, by intention. So now we have 4 types of non-probability samples, and these 4 types are the convenient sample, the snowball sample, the quota sample, and the purpose sample. Probably we'll take some examples also to make things more clear. The quota sample. We said the convenient sample, we know we take all. And we spoke already about the snowball. We gave examples. Now they say the quota sample, which is heterogeneous inside, containing so many different things. Anyhow, in the quota, here we do not, for example, let us see this example. Presentation and mode of presentation and management of breast cancer or thyroid disease, not thyroid cancer, thyroid disease, because so many types of thyrotoxicosis, Graves' disease, and multinodular goiter, solitary nodule, whether it is toxic or not, and so on and so forth, and malignancy, or thyroid or breast cancer as such. Amid Sudan War, a quota sample analysis. Now we take the sample containing different types, females, young females, elderly females, or we take, if we are going to take it stratified, we are going to take 3 stratas, for example, the young females, and the premenopausal, then perimenopausal, and a 3rd strata, postmenopausal. Here, it is just mixed, and then we are going to take from this mixture of breast cancer to study the outcomes and the mode of presentations. And the same thing for thyroid disease. We do not specify this type or that type. Whatever type of thyroid disease, we just select them from males, females, whatever, any group, any benign, malignant, we just select them and we analyze the sample. This is the quota sample. And we take another example. The purposive sample, practice variation in appendicitis management amid Sudan War, a purposive sample selection. For example, if we would like to study the management of appendicitis in Al Ubaid Hospital amid Sudan War, it is not generalizable to management of appendicitis in Port Sudan or Atbara. Probably some patients there, a high percentage, might be treated conservatively. They might be given antibiotics for 24, maybe, I say maybe, antibiotics for 24, and they send home after that if they improve. In Port Sudan, Atbara, maybe they will operate it just to fast after arrival to the hospital, 2-3 hours fasting, and they take them for surgery for removal of the appendix. So by purpose, by intention, if we select a disease in certain area, which is not representative to other hospitals or to other settings, this is a purposive sample. And usually we said it is dictated by access to the population. It is dictated by the access of the population. However, the 4 types of the non-random samples are carrying bias of selection. And I repeat again, these are the convenient sample in which we collect all patients together, and the snowball which keeps growing, every group nominating the next, every group nominating the next, or the quota sample containing variations of age groups and sex and different patterns, and the purposive, on-purpose selection of the sample. Now, the challenges and limitations, as I said as before. It is either if we are following up patients in prospective studies, some patients get lost. Either they were displaced by the war to other places, or they die at home, or whatever happens, they do not come back to hospital for follow-up. This is attrition. And to replace this, we have to add some more number between 10 to 20% to the sample size. 10 to 20% of the sample size should be added to the sample size to compensate for these losses. And in retrospective studies, if there is some missing files because of the problems of the war, then we have to add some more files to the sample size to compensate for the lost files. And we have to make sure that the data of every individual has been entered correctly, and no individual should have his data entered twice. This is data cleaning. And again, I remind you with the imputation, that if certain files or certain patients did not have complete set of variables or data, then we correct it not by eliminating these individuals, because if we eliminate them, the sample size will be small, not representative, the calculations will not be accurate, it will not be generalized. So we keep them as it is, and we correct it by statistical methods, and we should consult the statisticians. Does he use this method of imputation, not amputation, imputation, ta'weed? Does he use this? And we said for continuous data, we use mean and median, and for categorical data, we use the mode. Anyhow, this is another subject, not to complicate things. To this point, I will stop, and next time I will speak about the tools we use for collection of these